So I'm Anushka, and I'm the AI and blockchain lead at GDSC at our university. And today I'm um, going to go through data sets by using the Python module pandas, and we'll make a line chart plot with matplotlib module. It's all going to be in Python, and I'll be using. First step is, in case you guys don't have these two modules, then you have to go here, have to type pip install matplotlib or pandas. Then just enter, and it should do two modules of pandas and matplotlib. Then before I start, I already have my data set ready. Where I got it from. There's this website called Kaggle, and if you here, then there are data sets available. This is where I got mine from, categorized by topics, and I just click on it. Then you have everything in there, IDs. It's basically like a table with rows, and it's usually in CSV format, and you can download it while you're signed in on this website. I downloaded it and I put it here in same directory as my Jupyter notebook. So my notebooks, and then I made a file, and then so the data set I downloaded is stock prices daily from 2017 to somewhere in 2022. Okay, and the three companies I focused on is Google, Meta, and Apple. This is Jupyter Notebook, any other code editor. So let's import pandas first. We'll do pandas first and then matplotlib. Import pandas as PD, right? Anything instead of PD. But this is the convention that everyone follows, so I'm gonna write PD, okay? First step is we get the data set into this. Yeah. PDF is the name of the variable I'm using, so PD dot open underscore CSV. I told you the one I downloaded is in CSV format. So it can be Excel, it can be TXT, whatever. So you do open underscore Excel, open underscore TXT. That's the function you have to use. Okay, and then as parameter, you give the file name. My file, I'm going to. Now, as I showed you, it's in a. Here are the notebooks, and I made another folder, and then here's the data sets, right? So let me just add the path. In case you're saving it anywhere else, you need to put the whole. Slash. Okay. So if now and run this. Okay, so this is the data. Have the column names are date, open, high, low, close, adjust, close. Now, what do these mean? Is it's seeing the stock prices from, as you can see, 2017 till 2022, and there are 1,258 rows. Okay, so date, open is now a stock market opens from around 9 a.m. in the morning and then closes at 4 p.m., right? So this is the opening price of every day, and then it goes up and down depending on how many buy it and sell it and all of that, and it closes at a rate, right? So a high column is the highest price of the whole day, and then low column is the lowest price of the whole day. And then adjust close is after the market closes, there are some calculations to do. That is what adjust close is, the final price after the market is closed and after the calculations are done. And then volume is the number of stock shares that have been traded in the whole day. Okay. when you open a data set, the first thing you want to see is columns. So how to do that is you write df dot columns, then run it, and it gives you a list of the whole. Okay. Now, as I said, date, open, high, low, close. Okay, adjust close is a little more complicated because I just vaguely told you that they do some calculations. So let me just omit that. Okay. So what I'm going to do that is I'll reassign the same thing, but this time I'll just mention the uh, the columns that I want. Hence, write date. I close, and these are the columns that I want, and I'm not writing adjust close. So it's only going to take the data in these columns and then omit it. If I write print df again, I'll just you can see now it just has date, open, high, low, close. So this is the data set that we're going to work. So if I want a single column, like if I just want to see dates, then I can just do dot date. Like you guys have probably heard about object oriented programming. So like an object in data frame. DF stands for data frame. Okay. So when you read a CSV file into this in this line, it basically converts the CSV file into a data frame, and pandas, all the functions are working with this data frame object. So out of this object, I'm asking for the date. So if I run that, here you see only the dates column. Now, I suggest instead of this syntax, you should probably use these square brackets instead. Why? Because if you now you can put any name for these columns, right? If you say date space of the day, if you add like a phrase, then when there are gaps, it's going to be a problem with the syntax. You can't put gaps in variables, right? So it's better if you put it in a square bracket. There are two types of syntax. One is dot date and the other one is this. And I think this is better because you don't have that issue with gap brackets and all. I mean gaps, like spaces. Okay, so now you've opened the file. You see the whole data set, you see all the columns. Now let's try to like be a little more specific, like see the rows. Okay, so there are a couple ways that are listed out here. So let's start with the first one, head and tail. If you want to see only the starting like first 50 rows, because there are like 1200 something, right? It's too much to work with. So let's just see a few in the beginning. So df dot head, and then here you put a number. So if I type 50, I'll see the first 50. As you can see, it starts off with somewhere in September 2017, and it is supposed to, the whole data set has until 2022. But here it shows like November 2017. So it's picked the first 50 rows. Same thing, you write df dot tail, and then maybe like 30, any number, okay? Then it's showing you from somewhere in July 2022 to September 2022. Okay, so two ways to read rows are head and tail, starting or ending. Now let's get a little more specific. If you want to see only a section, like in 1200, you want to see like 500 to 600, you can do this. You can like slice it. If you are slicing in lists and strings, you can do this. What I'm going to do is we have 1200. It's too much to work with, right? So what I'm going to do is I'm going to slice it and take every 10th value. If I run this, you can see now that it's picked every 100, 200. When I ran it twice. There's an issue with Jupyter Notebook. Like run only a section of it, it applied it twice because of now it's okay. So I sliced it to pick only every 10th, like I reassigned it. And now it's picking only like the first, like index number 0, index number 10, as you can see. And only these rows are just created, and it picked only 10, 10, like every 10th row. Okay, so now from 1200, we got it down to 126 rows. Like manageable to do, right? Okay, so we've done the slicing. That's one way to like access part. Okay, I want 20. Brings me 20 rows. Another way to access a certain part in the middle, not the beginning or end, is slicing. Okay. The next way is you want specific indexes. You want the second or third or 100th or 200th, something like that. So for that, you can do, you might think just like lists and all, if you just write the index like here, if I write 5, I'm going to get it, but there's actually a special function for it. If you do it like this, it's going to give an error. So you use this called iLook. Stands for integer location. So you put in integers or index, like index location. So if I type 6 this time, then you get the 6. You have all these. It's playing it in a different way, but this is one way. And then if you want a specific cell, like row number 5, row number 6, second column, then you write both of them, like row and column, and you get this particular. We finish starting and ending somewhere in the middle, and then a specific cell in any part of the whole. Now, something more useful would be to apply a condition and see everything that comes under that condition, right? Because programming is in the basics that you already conditional statements that. So integer location, you can only add integers or indexes. So if you want to put conditions to the whole thing, you have another function called location or look. So this time inside you don't put in integer or index, instead you put a condition. So suppose I want all the rows where the close price is above 75, okay? F dot close is above 75. I'll run it. Yep, the close, you can see everything. Now, if you want to add more conditions, then add more. It be only should be less than, you don't want anything from this year, and you can type 2020 at quotes. So this is enough. Add. The close price is all above 75, and dates you have 2020 to 2021. You don't have 2017 here. Okay. One thing you need to remember is in normal Python, when we write if statements and all, we usually write the word and, right? You don't put this symbol. But then this is a convention in Pandas module. So when you're using this, you need to write the symbol, because see, if I type and, it's going to give me an error. Same thing if I type the symbol once, it runs. Okay? So we learned how to open files, we learned how to see columns, and we learned how to access specific parts of the whole data frame, right? So let's go into updating this data. So let's add a new column. Okay, for that it's pretty simple. You just add the column name here. So suppose you want to add, okay, and its value. You can either give an array of the whole list of values, but it's 126 rows. I'm not going to do that. So I'll just add 0 here. Okay. So let me print the whole data frame. As you can see, everything's the same, but you have with all of it as 0. I could have sent an array of every value here, but I didn't do that because it just takes a lot of time. I just put 0, so it just gave all the values 0. Now, if I want to get rid of this, then I have to do f dot drop and then columns. Give this as parameter. Give the column. I'll write new column. A typo right here. I wrote M. I'll just change. Um, Updating the data. We learned how to add a new column and delete a new. And if we want to edit specific rows or like based on a condition, then do this. We use location, okay, and then we add the condition. So I want to change a very specific. I'll say date is 2022 6. Okay, I just chose a random date, and this is the condition. Now, if I just run this, it's just going to show me that one row, right? Okay. But if I want to change this, then I'll add another parameter. I'll mention a column name here. Suppose on this specific date, I want to change the open price to, let me type 110, okay? So I'll type open and I'll assign a value to this, 10. Print this. That this specific date has been changed to 110. So if I want to like, I'll just put this back so we don't mess with our data. I'll make this back into 100. And again, it has been changed to 112. Price, date, 200. Okay, so by far we learned to open a CSV file, or you can open Excel or TXT, and you just change the CSV to that particular type of thing. And then you can learn how to columns, see the columns, and then change the columns pick specific, see the data under one specific column, open rows specifically, whether it's in the beginning or in the end, open specific rows and like slicing it and then seeing only a part of it. Okay, so slicing it and seeing a specific part of it, specifying indexes of the row and column, and searching based on a condition. Okay, and then updating data, we created a new column and we dropped the same column and we edited the row values as well. And we'll see how to like add rows as well in the next few parts. Okay, right now I added a column and I I changed column type and then I changed a cell, a specific cell. And we'll see a whole row later. Let's go through some more functions that you can apply to this. df.describe. This basically gives you a bunch of values. It counts all the rows. Like in many data sets, you have missing values. Like if you collect it from people who are filling a form, there's some mandatory parts that you fill in, and sometimes like a contact number, the place you live, your age, all of that might be optional, right? So some of the data you get is, I mean, if you put all this in one big table, some cells will be missing and some will be filled up because you didn't make all of the data you collected as mandatory. So like that, you can get the number of cells that are like filled up with some value. Here we put our whole data set was filled everywhere. That's why our count is there as 120 all columns. And then we can get mean in this, the minimum stock price in all of these days together, the maximum, and yeah, there's just a bunch of statistics over it. Another function you can use is sorting. Sort underscore values is the and you add the column name. Suppose I want to sort it by dates are already sorted from 2017. Let me pick volume. As you can see, volume starts off at 125 and ends at 816. So it's increasing from the beginning. So it's in ascending order. So if you want to do this in descending order, you have to add another parameter that is descending false. If you do this, then as you can see, the highest value 816 came on the top and 125 below. So it's descending now. Okay, another thing you can do is, we saw the whole thing, we saw different parts of it, we learned how to make changes in it, we saw some values like sum and count and maximum, minimum, and after doing all the changes, when you want to save it, because like this is not changing the file values itself, it brings the data in and makes it an object, a data frame object. All the changes you're making in it is in that object and not the file itself. So if you want these changes to be saved, then you use df.tocsv underscore csv, and then you give it a name. So if I type Google underscore modified, you can give it any name, and then mention the type, like csv, the extension. Then it's going to get saved in the same directory. Okay, I don't want this. We did most of it, but let me show you a few more things. There's also options like joining and like as I said, I'll tell you how to put like many rows together, right? So suppose you have two different data and you want to like combine all the rows, you do that. And if you want to like group some parts, like grouping can only be done if I have like suppose my data has a column like type 1, type 2, type 3, all of that, then I can like group it according to that type, right? Now I want to show you that, but my data has mostly like numbers, like stock prices and a date. So there's no type kind of column yet, which I can use for group. So let me make something like that. I have loaded in the Google CS.csv file. So let me add a company column for the type part so I can group it together. So I'll make a new column called company. We have this, now let us bring in another file. Now I have Google, Apple, and Meta, right? So let me bring in Meta. So How do you bring it in again? I'll call this df2 equal to pd dot read csv. Then you add in the name, right? So data sets slash meta.csv. This is that other CSV file has one to just like how we had it before. So let's do a thing. Let's get rid of these, the adjust close first. I can get rid of that. I'll write it all in the same line. You can do that. On this. As you can see, we got rid of adjust close. And now let me also get rid of like so many rows, and I'll make it 126. What I had done before, I had taken every 10th of the value, right? Let me do the same. I sit down. As you can see, it took the 126, just like the. So let's make the same company column, but this time it's meta. So let's do that same thing again. Now we have the same thing, just like previously, company. Now we have two types, companies, one is meta. So let's group these together. And I'll make this as df3. How do you group them together? pd dot concat, this concatenation. I'll add the two frames together, F2. Now we have both of them together. Okay. Now we use concatenation because all the columns are the same in both. But in case they weren't the same, it's like SQL joins. So over here it's the same, so we use concatenation. But in case like suppose we had two types of tables. One is a student's information like their MySys number, their program they're studying, etc. And then one was just the MySys number and their grades in a particular module. How you had to join them together, you can't use concatenation because the columns aren't the same, right? In that case, you would use a merge function. But here, it's the same columns. You just want to like add the values in the end. So it's like how it just adds these columns. Okay, that's done. Now let's group these together. Okay. And the column that I want to group this based on is company, right? Because we have Google and Meta. Let me write that company. We have 126 here, and then pricing didn't actually happen. So we have 126 rows of Google and then whole data set of. So, another one adds up all the prices together of each value. Then we have mean. And this, so under Google, the mean price under like opening price is 82, and meta it is just, let's just go through it. We open the files with read CSV, and you mention the file name. In case you have the data set in another format, you can do read underscore Excel, read underscore TXT, etc. And if it's not in the same file, like folder as the mentioned path. So mine was in a file, so that's why I only mentioned data sets. But if it was in a completely different place, I have to mention the whole path. Okay, so we open the file, and then came accessing data. So you use head or tail to access the first n rows either in the beginning or the end. Then columns gave us the list of the column names. And then if you want to see a specific part, you can use slicing. So if you want to see row 50 to row 100, you write 50 colon 101 and you get the whole thing. So you use slicing just like you use in lists of strings. And if you want to see a specific column or a group of columns, you mention it over here in this format. Okay. So if you want to see specific indexes based on indexes, then you can use the iloc function. So you put if you put 6 here, you'll see row 6, and then you can slice it. Or if you want to see a specific cell, a specific value in the row, then you put both row and column value, and you get the good. Then these were based on the indexes. So if you don't want indexes and you want to see it as a whole, and you want to see how many stocks are above this value, or how many stocks were traded from this day to this day. So for all of that, you'd use the loc function, and yeah, you just specify the condition over here. In this, it's a particular value, but you can put less than, more than, and all of it. Any conditional statement can. Okay. So next is you need all of the data, and if you want to change anything, you can just define it like this, the column and value. If you want to give a different value for every single row in the whole column, then you put an array of all those values. But if you just put one value, then for all of the values in the column, you're going to have the same. So that's what I did. Okay, and if you want to get rid of the new column you made or any old column, then you can just drop it. Then you have here, if you type this with the conditional statement, you'll just see it. But then if you mention another column and then assign a value to it, then it changes. So any row that satisfies this condition, its value under this column is going to change. Okay? And then if you have two different data frames of the same of the same columns, and you want to just put those rows together, then you use the concatenation function. And then if the rows are different, but it has at least one similar column, then you use merge. Okay. And the format for that is you put the data frames here. So like df1, df2, you can put it like that. And then you mention on which column, based on which column you're merging them together. So if you give that example I gave of the student details and then the student, the MySys number and the grades in that particular module, then you'd put MySys number column on place. Okay. And other than that, a few more functions we went through is describe. It basically gave sum, maximum, minimum in each row. And then you can sort it based on a specific column ascending to a false. It's by default true, but if you want to descend. And then finally, when you're done with all your changes, if you want to save that data, as I said, because it's just importing the information, not changing the original file. So if you want to do that, then you have to use to_csv and then put a name.csv. Get saved in the same directory. Okay, if you want to see all the unique values under a column, then you can use .unique function. And so as I said, when you collect information in a form and you have some parts as mandatory, some parts as not mandatory, then you have some missing cells, right? So in machine learning, you want to like regulate all of this empty cells. Either you get rid of the whole row or you put something else in place. So one way to deal with that is you can just drop all the rows that have none values, non-use, like there's nothing in that place. So df.drop na, this function is going to just drop all those rows that have some cell empty. But in machine learning, it's recommended not to use this because data is like extremely important. So instead of this, you can just put another value instead. So this second last function that's here, fill and none values. So you mention a value and then like if the place is empty, then it's just going to fill it with this. Now, whether you can use this or not, it depends on the way, context basically. Like in ours, we cannot use this because our data is full of like numbers. If I put an opening price, if I don't have an opening price of a day and I put it as 0, it's not going to mean there is no value at all. It's going to mean the share of the value has dropped down to 0, right? But if I put company name, if it's empty and I put 0, it just doesn't make sense. If like unless a company is called 0, 0 will mean like we don't know the companies. You can add unknown or 0. So it depends on the context. But these are the two ways you can deal with such empty values in a data set. Okay, and then finally, for analysis, if you want to like group some parts, we did that. And then you want to count the number of rows that have a value in it. And then the mean of the whole column, sum of the whole. Okay, so we finished dealing with pandas. Now let's do another thing. Let's use matplotlib. This is a library that you can use to make graphs with the data you have. So we'll be doing that next. Okay. So let's import it first. Keep in mind that if you don't have this already on your laptop, you have to go on the command prompt here and then type pip install matplotlib. Okay. I already have it, so no. Mat.lib .pyplot. You don't want the whole thing. Just want this. As PLT. This is also convention, just like pandas is referred to as PD most of the time. Matplotlib.pyplot is as PLT. So that's what we're going to do. Okay. So what I'm going to do now is I'm going to take the, I'm going to graph the volumes. Okay, not price. I'll do volume. If I just write df.volume, df2.volume, it's all in data frames, right? And we can't deal with that over here. We deal with lists mainly. So let me make those into a list. I'll just use the list function and I write df.volume. So it's going to pick up all the volumes in the volume and make it into a list. Let's just see that once. As you can see, all the volumes are in. Okay. I'll do the same thing with meta. List. We have 2. Third. You can write it in this format or you can put the square brackets in. Second. We have 126. So if we check this list now, we have 126 volumes over here. One in the list. So now let's graph this. Already defined dates. Now in the graph, how I want it to be is I want the x-axis to be the dates and then the volumes graphed on the other side. Okay. I'll make another list of the dates. The dates are the same in both the data frames. So I'm just going to pick the first one, date. Okay, so we have, this will be our x-axis and these two will be plotted as the y. Let's do the main part. So you have to do plt dot plot, and then here I'll give the x and y values. So I'll put dates here, and I'll first do Google. As you can see, we got, but dates are not visible properly with that later. But volume part is pretty much okay. 1e7 means 10 raised to 7, like exponent 7, okay? So because like the numbers are like really, really big, right? It's in like 100 millions range. So 7 into 10 raised to 7. Like that. This number into 10 raised to 7. Okay? So this is Google's plot, right? So let's plot the next one as well. plt.plot. We already have dates as x-axis, so I'm just going to send in meta. So we have the orange line as Facebook now. I mean meta. It's a little, you feel like something's missing, right? We don't have names. We don't have, we don't have like this box telling us which one is Google and which one is Meta. So let's deal with that. After x and y, I'm going to add a label parameter, which is equal to, I'll just name it Google. Okay? And here I'll name it as Meta. Same thing, label Meta. We label the two lines, but to make it visible, what you have to do is you do plt.legend. Okay, this line is what's going to make the box visible. So if I run it now, you can see this. Now, if I didn't write this line, even if I give these labels, this is not going to be seen. Only after I write plt.legend, this box is going to. So we added this. Now let's add just the last few steps. We'll add a name for y-axis and x-axis and the whole plot together. Okay. For that, what I do is plt.title. Add a title to the whole graph. So I'm going to name this stock volumes traded. I'll run it and you can see that. We named the whole graph. Now let's name the axes. plt.x label. Name this dates. Then plt.y label. That is volume. Okay, I'll run this. And yeah, we have stock volume stated up here. X-axis is dates, y-axis is volume. Now, before we end this, it's mostly proper, but then the only problem is the dates are looking really messy, right? Let me do one thing. It's showing every single date. Like I have 126 and 126 rows put together. So, oh right, the dates part is the same. Basically, it's all these ticks are like 126 dates all lined up one after another. So how do I solve it? So let's change the format up a bit. Last few steps, okay? plt.x ticks. Now ticks is basically, I'm not touching the actual data that I sent into the plot. Ticks are just what is like visible to us in the graph. Okay, so the ticks, like the y ticks over here is 0 0.00, 0 0.25, 0.50. All of these are like y ticks. So this is like, okay, but x ticks are the problem here, right? What I'll do is I'll define the x ticks myself. here I don't want to like write it, it's going to take a long time. So let me just take the dates list and then slice it up. Just like before, I'll just take every 10th because we have 126 dates being displayed down. If I take every 10th, then I'll only have like 10 to 12 parts, right? Let me run that. Time, as you can see, it came down a lot lesser. There are probably like 10 to 12 pixels. Now to get rid of all this, I'll just I'm on Jupyter Notebook, and for me, even though I didn't write that show part, it just kept showing. But then if you write it on like a Python IDLE or something, then even if you write all of this, if you don't write show, it's just not going to give you any output. So you need to write show. It's recommended to like always write show. Okay. So we wrote the ticks and now it's visible properly. And one last step, it's the ticks are proper, but still some dates are like overlapping, right? So let me just do this one thing here. Let me write PL. Just don't worry about what I just copied it to just format this properly. Like just remember it as a whole and don't break it down. If the dates are overlapping and they're really long, it'll just change the format. Let me show you. I run it again, and this time everything is okay. Showing it slanted. So this line basically just formatted it in a way it just shows sideways. Yeah, so our plot is ready. So let's just summarize what. So the first step was plotting. Now you give an X value, Y value, label, color marker line is the color you wanted, and I'll just show you. Just about formatting and how it's like visibility. Let me just add it to. Let me add it to the first plot. Okay. So we have dates X and Y and label. Let me just add colors to it. I'll put as green and I typed a dot and then like a full stop and then uh, and a hyphen, right? What this means, first one is G. G stands for green. Okay, it's all spelled out in the Matplotlib documentation. So if you wanna like see what letter responds to what color, you can see it over there. G over here means red for green. R is for red. B is for blue. So it's like that. I'm just going to show you one example so you know how it works. Okay, so this color marker line, you can spell it out like label is equal to Google, comma, color is equal to green, comma, marker is equal to dot. But then this is like a shorthand format. So G is for green, dot is for the points to show that specific point, and the hyphen is to like join the whole thing as a whole. So if I run this again, now you can see only for the Google stock, there are points and it's in green and it's by default, the lines were already connected, that is by default, but I just specified it over there. So it changed to green. It shows each point as a full stop and it joins each other by lines. So if I add another dash over here, it's going to show it as like dotted, these kind of lines. They're different like formats. You can see it on the Matplotlib documentation, but basically, yeah, you can also like change the font type, the stock volume stated. If you want all of this written in another font type, bigger font size, all of that stuff, then you can just specify all that. It's all there in the documentation, but I didn't mention it here because like it's just not that important to like change the type of font. And one last thing before we end, if you if you just change these dimensions, it'll look prettier, right? So let me just do that. Up here in the beginning, I'll write plt dot figure, and then I'll specify figure size, fig size. Okay. I'll mention this is not saying it by inches, okay, or any format. I mean, any like meters, centimeters, inches, none of that. We're just specifying like comparatively. Like this is 5 units, this is going to be 10 units. So X this many units, Y this many units. So the image looks like X is a little bigger than Y. So what I'm going to write here, I'm going to write 15 and 10. Okay, it's just an approximate. And I'll add one more parameter called DPI. DPI is dots per inch or pixel per inch. This is what you have to write when you want like a big plot. So if I add this around like 300 and run this, it should be a lot bigger. Yeah. So this makes the whole thing a lot more clearer, right? So yeah, we're done with doing the plot. Now you can save this either like this or you can save it over here. Type. I'll show you in the. Let's just summarize what given x and y values to the plot function. If you want, you can add the others like color marker line. This for this I type G dot and hyphen, basically about what colors and how you want the whole thing. Instead of this, if you had put like an exponent thing, then you would like instead of circles or dots, you'd see like little triangles and stuff. Okay, and then label is for the legend box, and then there are a couple other parameters. Check the documentation if you wanna like add font type and all of that. But this is the basics, okay? And then legend, this line is very much necessary if you want to like see that box in the corner. Read. Let me just type here. Read. It's just gonna like show lines for you to like read the better. Yeah, like that. Just adds a grid to the whole. Okay. And then to add labels to everything, this is for putting a title on the whole graph. Want to specify the labels for x and y, then you just add the name like x label is one function, y label is another function. Okay, if you want to specify the ticks in the sense the numbers that are shown in the graph, you're not editing the main data that you're sending it, you're just showing it what numbers you want. You can write x ticks and then give it an array of values. You're going to show them. That's what we did with y because the dates were just too long and okay. And the last few figure, this one we used to like resize it. Here we mentioned like compare the dimension, like this one is 15 units and y-axis is 10 units. You can put anything and it's just going to be proportional to that. And then DPI is dots per inch. It's basically for clarity of the image size as well. Like I put 300 and it became like big enough. Clarity and dimension and show is necessary in the end of every plot. You should put that. And then this is the save fig. For this, as I said, if you right click on it, you can download the image, but you can also do it through Python. You have to just use the save fig function and then give it you write this, it's going to save it in the same directory. And then today I showed you a normal line chart. But you can also, in matplotlib.pyplot, you can also make bar charts, you can make pie charts, you can make histograms. So there are a couple different types. But today, because we chose a stock market data set, I thought a line chart is more. Okay, so I used that one. That's it for today. Now about the further sessions that we're going to have. Today, my aim was to just make you familiar with the functions under these two modules. And we were just generally going through what each function does, right? So it's next time it's going to be more complex and we'll do a specific task. Me or Hamida will do it. That is our data science lead. So one of us are going to shoot to like analyze a specific like a data set, and then like when you're trying to do an analysis of a specific data set, you start off with questions like for example, if it's a stock market data set, you might want to ask which stock performed better in this year, or like when was it high, when was it low. So basically you start off with this analysis by asking questions, right? Like that. So next time we'll do the same kind of thing but in a more realistic environment, in the sense maybe a company might ask you to like analyze the data set and come up with when we during this time this is the strategy that we use how much did that benefit our company, those kind of things. We'll pick up a specific issue and then use the same modules on it, but in a more complex way, in a more useful way. Okay. And then I'm going to cover other modules under machine learning like NumPy, TensorFlow, scikit-learn, Keras, all of those. I'm going to cover it over the next few weeks. Now, and blockchain, I will be doing it after the winter break in January or something once I'm done with AI. Okay? And all of us, we are not limited to the one or two topics that we pick. Like mine is AI and blockchain, right? I'm not limited to that. So anything that I think you guys might be interested in, I can do those. One thing that I'm going to do is intermediate Python session. In the sense, we all already learned control flow, loops, all of those like basic things. But in intermediate Python, there are these little things I learned as I went ahead that are like in general just useful. It makes my job easier. Like you guys might have heard of like lambda functions, map function, filter function, regular expressions. So like these little things that just make your life easier. Like you can always do loops and if statements and all, but if you can like cut that down into like one or two lines instead of like four or five or then there's some tricks and some functions and some more in general. So that's one thing I want to do. And then I also want to do data structures like linked lists, trees, bigger notation, time complexity, all of those stuff. They say it's like really, really important. Those are the things on my mind right now. You guys can always come ahead and tell us what you guys are interested in. We are there on Teams. You can mail us. You can message us on Teams. You can message us on Instagram. We're all on LinkedIn. And there's also WhatsApp. Yeah, so, yeah. Please come. Don't. Even if you have syntax errors, like it's okay. You can contact us. And it